Hello, and welcome to part 2 in our module on Android support for programming concurrent and network software. In part 1, we had presented an overview of the Android software architecture, describing its layers and some of the key framework components it provides to applications and reusable services. In this part of the module, we're going to present an overview of Android mechanisms available to implement networked apps. In this context, network means two things. First, it means internet-enabled apps, things that can communicate over HTTP and TCP to remote servers, perhaps in a cloud, as well as local inter-process communication that takes place between processes running on the mobile device itself. There won't be any code we'll cover here. We'll cover lots of code examples in later parts of the course. First, let me give you a quick overview of Android communication mechanisms. Android provides quite a number of mechanisms for local inter-process communication between different processes on a device itself. The particular ones we're going to focus on in this part of the module is the Android binder and AIDL mechanisms. AIDL is the Android Interface Definition Language, and the binder is an object-oriented remote procedure call mechanism that resides partly in the middleware and partly in the Linux kernel. Here's a quick example of how you can use the binder and AIDL. An application would go ahead and bind a service, an activity would go ahead and bind a service, which would call an operation called onBind on the service, which turns around and gets access to a local implementation called a binder object, because it inherits from binder, and returns a proxy to that binder object back to the activity, where it's then stored in a local data member. That local data member can then be used to go ahead and invoke an operation, such as download image, back on the service, and a stub running inside that service delivers that method back to the binder object, which does its work and then returns a result or does whatever it needs to do with that case. There's a lot of description about how binder works at the URL at the bottom of this slide. Keep in mind again that binder is used for communicating between processes on the same machine. This example used a download activity talking to a download service, but you could also have services talking to each other by the binder as well. The other type of mechanism that's available in Android is true internet communication. Many Android applications need to access services and communicate and receive data via the internet. Browsers, email, calendar, contacts, maps, and so on. These applications typically use sockets and TCP and or HTTP to communicate remotely across the network. There's a nice tutorial in the Android website that describes to you how to program sockets and HTTP with the mechanisms available in Android. So let's take a little bit deeper dive inside of the Android binder and AIDL inter-process communication mechanism. The binder provides local remote procedure call for cross-process calls. So you're going from one activity in one process to another service or another capability or component in another process. Under the hood, there's actually a driver called the binder driver that runs inside the Linux kernel, and it uses shared memory and various thread pools in order to be able to accelerate and optimize the communication between processes. One of the interesting things about the binder mechanism is you can use it not only to do Java to Java communication across process boundaries, but you can also use it to do Java to C or C++ communication, or C++ C to C++ C communication in other processes. So you can talk in a variety of ways using several different languages and different optimization points. If you take a look at this URL, you'll find more descriptions of how binder works and has some nice diagrams illustrating the control flow that goes back and forth with binder. AIDL, or the Android Interface Definition Language, is a Java-like interface that allows you to export methods from one object in one address space to be used by other objects or components running in other address spaces. Here's a very simple AIDL interface that defines a download image interface with a download image method. The caller's data is marshaled into something called parcels. And this is done by a proxy that's automatically generated by the AIDL compiler. And this parcel is then copied from the caller's address space into the callie's address space, and it's demarshalled into the format that's expected by the callee. And that's then, of course, dispatched through a stub to a real method that you would typically define if you were writing the service implementation. By default, AIDL supports synchronous calls. So what that means is that the caller thread is blocked until the callee returns a result. If you apply various patterns, such as callback patterns, it's straightforward to do various kinds of asynchronous communication using the binder mechanism as well. And there's a nice description of AIDL here at the Android website that'll give you more insight about how it works, how the compilers run, and so on. If you use Eclipse or some other similar integrated development environment, it's actually very simple to use AIDL and integrate it with your programs. Well, there's obviously more to communication in Android than just talking between processes on the same device. And for that reason, Android provides a variety of different network programming mechanisms. It includes the Java.NET interface, which are the socket and various socket server and URL classes. It provides the Apache interface. It also applies something called Android.NET. And these are all Java interfaces for being able to access sockets or lower-level mechanisms for communication, as well as more web programming interfaces using HTTP. Under the hood, the Android HTTP libraries use the Java Sockets API. And if you go even deeper under the hood, the Java Sockets API actually uses the underlying Linux C-Sockets API that we had talked about in the previous module on OS support for networking mechanisms. Sockets, of course, is a very, very common way of doing communication in a wide variety of different operating environments. Here's a quick summary of the way that Java sockets work. They're a little bit easier to work with than the native C sockets. They remove some of the accidental complexities of programming at C, but the basic idea is more or less the same. You have a couple of different roles. You have the passive role and the active role. The passive role is played by something called a server socket. And it defines very familiar mechanisms like the accept method, bind, and close. And it basically allows you to have a factory that will manufacture a socket to communicate with a connected client. The active role is typically played by a socket, which allows you to connect to a server, as well as be able to bind to various addresses, and also be able to get access to input and output streams that are used to actually communicate back and forth between sender and receiver. So the communication role is the third role, and that's where you do the business logic communication using input and output stream. And Android has quite a number of different ways to interact via various Java classes and Java I/O decorators that are used to make it possible to communicate using connected sockets. So to summarize this section, Android provides a wide range of local and remote inter-process communication mechanisms. Here are some of the books that I use in the courses I teach at Vanderbilt University on Android systems programming. I also use some of the material I find online to help augment those books. There's a wealth of information about Android network programming that you can learn about by following various links and tutorials online. It's also worth pointing out that there are many interesting patterns that underlie these Android inter-process communication mechanisms. For example, the wrapper facade pattern is essentially what the Java networking libraries and Apache libraries and so on, and Android libraries for networking do to encapsulate the lower level, tedious and error-prone C interfaces, which are full of accidental complexities, in order to provide a much easier to work with, much more extensible, object-oriented facade to these low-level networking mechanisms. There's some other patterns as well. For example, the AIDL and binder RPC mechanism implement the broker pattern. Likewise, some other ways of being able to start up services, such as the start service method, can be used to implement the command processor pattern. We will talk at length in later sections of the course about these patterns and how you can use them effectively when you program Android applications. So it's important to have a good understanding of the basic mechanisms so that you have a way to understand what we'll cover later when we start describing the way in which the patterns and frameworks augment and enhance these basic Android networking mechanisms.